Hello everybody, welcome into another lesson. So today we are going to talk about solving radical equations where you have a radical on both sides of the equation. Here you have the square root of 2x minus 1 equals the square root of x plus 4. Well, like with yesterday's lesson when we had them on only one side of the equation, it's pretty much the same process. You're going to have to raise both sides to the second power. So if we do that, you end up then with 2x minus 1 equals x plus 4. Then just solve for x, you would end up literally getting x equals 5. But we're not done yet. When you solve any radical equation, you have to check for extraneous solutions. So that means we have to make sure that x equals 5 will actually work, that it won't give us a negative value under the square root, or it won't give us a false statement where the left side doesn't equal the right. So put that x value of 5 in where the x is. So on the left side, you would get the square root of 10 minus 1 would equal the square root of 5 plus 4, which would give you the square root of 9 equals the square root of 9, which would give you 3 equals 3. That's a true statement, so x equals 5 does work and is the solution in this case to this radical equation, since there's no extraneous solutions. Alright. So we have the fourth root of 6x minus 5 is equal to the fourth root of x plus 10. Alright, so the fourth root of 6x minus 5 equals the fourth root of x plus 10. Well, both sides have a fourth root, so we have to raise both sides to the fourth power. If we do that, you'll get 6x minus 5 is equal to x plus 10. Then we'll just solve for x. Okay, good. Which that would end up giving you 5x is equal to 15, which would seemingly give you x equals 3. But again, we have to check for extraneous solutions. So in other words, we have to make sure 3 is actually going to work. Since this is a fourth root, we have to watch for a negative value under the root since it's an even root. So put in that 3 for x, you'll end up getting the fourth root of 18 minus 5 equal to the fourth root of 3 plus 10, which would turn into the fourth root of 13 equal to the fourth root of 13. The left side equals the right, so we're good to go. So x equals 3 is the solution to this radical equation. X would equal 3. Now here's a good one. Negative of the square root of 8x plus 4/3 would be equal to the square root of 2x plus 1/3. Alright, so this is different. We have negative of the square root of 8x plus 4/3 equals positive square root of 2x plus 1/3. Well, still, we got to square both sides. And if you square both sides, that negative 1 will turn into a positive 1, so the negative sign goes away. You would literally just get 8x plus 4/3 is equal to 2x plus 1/3. Let's simplify this. You'll end up getting 6x equals negative 3/3, which would be negative 1. So x would equal negative 1/6. But we have to make sure that x equals negative 1/6 is not an extraneous solution. So let's put this in here. you'll end up with negative of the square root of 8 times negative 1/6 plus 4/3 is equal to the square root of 2 times negative 1/6 plus 1/3. Alright, so let's see. Negative of the square root, what is negative 8/6? In simplest form, that's negative 4/3. You'd have the square root of negative 4/3 plus positive 4/3 is going to equal the square root of 2 times negative 1/6. Well, that's negative 1/3 plus 1/3. So this will become negative of the square root of 0 is equal to the square root of 0. Well, square root of 0 is 0, and 0 is the only number that's neither positive nor negative. So you get 0 equals 0. So this actually works. X equals negative 1/6 would be your solution. Had we gotten any other value besides x equals negative 1/6, this would not work. Had we gotten any other value, if it were less than negative 1/6, we would have a negative under the square roots, which wouldn't work right away. Had we gotten any number greater than negative 1/6, what you would have had are still positive numbers on the square root, but you would have had a negative number equal to a positive number, which is also false. So x equals negative 1/6 is literally the only solution to this. All right. Two times the cube root of 10 minus 3x is equal to the cube root of 2 minus x. Alright, so 2 times the cube root of 10 minus 3x equals 2 times the cube root of 10 minus 3x equals the cube root of 2 minus x. Well, good news is, since this is an odd power root, x is defined for all real numbers. So we don't have to worry about if we get negative numbers under the root in this case. Under the radical, rather. But we still have to raise both sides to the third power, and in the end we still have to check for extraneous solutions. That would make a false statement where the left doesn't equal the right. But let's raise both sides to the third power. So what's 2 to the third? Well, that's going to be 8 times what's inside of the cube root. So that'd be 8 times 10 minus 3x would equal 2 minus x. Then do your distributive property. You would get 80 minus 24x is equal to 2 minus x. Simplify this, you get 23x equals 78, which would then give you an x value of 78/23. But it never hurts to verify, since you're dealing with a radical equation. Verify your work, check to make sure this isn't an extraneous solution. So here's where it gets a little ugly. So take 2 times the cube root of 10 minus 3 times that 78/23. Set that equal to the cube root of 2 minus 78/23. So this just became ugly real fast. Alright, so let's figure out what the heck is 3 times 28, by the way. I'm not sure. Sorry, 3 times 78. That's 234. So this will turn into 2 times the cube root of 230 minus 234 all over 23 would be equal to the cube root of 46 minus 78 over 23, which is going to simplify into 2 times the cube root of negative 4 over 23 equal to the cube root of negative 32 over 23. Now, here's where it gets funny. Some calculators allow you to put this in beautifully and will give you a real number answer. But if you have one like mine, and a lot of them do unfortunately, for whatever reason, it'll mark this as undefined even though it's an odd power root, which we know is a load of crap, because odd power roots can produce and do produce real number values for negative roots if it's an odd power root. So here's how you probably want to put this into your calculator. 2, actually take negative 2, because if you have a negative, you can extract a negative 1 outside the cube root, right? So negative 2 times the cube root of 4 divided by the cube root of 23, right? Because you could separate roots. Set that equal to negative of the cube root of 32 divided by the cube root of 23. Make sure you extract your negative, because otherwise it's going to be a real pain in the you-know-what to try to get your calculator to work with you. So let's take if I could divide today, 4/23. Now I'm going to raise that to the 1/3 power, which is the same as taking the cube root. Alright, I get approximately negative 1.116 on this side for the decimal. Basically what you're going to have to do is take decimals. Raise that to the 1/3 power. Yep, you get negative 1.116. This is basically just checking to make sure they match up. So yes, left side equals the right, so x equals 78/23 would in fact be your solution. And that was not a pretty solution, not by any stretch of the imagination, but it does shape out that way sometimes. So keep that in mind. I got like 4 more. Then we'll be done with this lesson. Alright, what do we have next? We have the 4th root of 2x plus the 4th root of x plus 3 is equal to 0. Alright, well, you definitely want to set this up where you have a radical on each side. So I would get that 4th root of 2x by itself. So let's do that. You'll get the 4th root of 2x equals the negative 4th root of x plus 3. Now both sides are raised to the 4th power, so let's take, both sides have the 4th root. Let's raise both sides to the 4th power, which would end up just giving you 2x equals x plus 3. It would give you what looks like x equals 3. But we're not done yet. We have to check and make sure the solution works. So if you take the 4th root of 2 times 3, well, that's going to be 6 plus the fourth root of 3 plus 3, set that equal to 0. So you would literally, let's see, get the fourth root of 6 plus the fourth root of 6 equal to 0. This is saying that 2 times the fourth root of 6 is equal to 0. We know that's not true, right? This is why you check your work. You got a false number in an extraneous solution, so x equals 3 actually has to be thrown out because the left side doesn't equal the right. So in actuality, there's no solution to this one. That does sometimes happen. That x equals 3 is what was called an extraneous solution. This is exactly why we check our work. Three more. Alright, square root of x minus 6 minus the square root of 1/3 x equals 0. Alright, so we have the square root of x minus 6 minus the square root of 1/3 x equal to 0. I would get that square root of x minus 6 by itself, so let's do that. You'll end up with the square root of x minus 6 equals the square root of 1/3 x. Now we got this in a form we can work with. So just raise both sides to the second power, you'll get x minus 6 is equal to 1/3 x. Let's simplify this then. You would end up simply then getting 2/3 x equals 6. And then 2x would equal 18, and then x would equal 9. But we have to make sure this actually works. We need to check and make sure that x equals 9 is not an extraneous solution. So let's check that. So let's see, the square root of 9 minus 6 equal to the square root of 1/3 times 9. Which would give you the square root of 3 equals the square root of 3. This actually checks out. So the solution in this case is that x equals 9. X equals 9 works and is the solution in this case. And I got two more. Okay, so the square root of 2x plus 10 minus 2 times the square root of x is equal to 0. So we have the square root of 2x plus 10 minus 2 times the square root of x equals 0. I would get that square root of 2x plus 10 by itself. So this will turn into the square root of 2x plus 10 equals 2 times the square root of x. Now just raise both sides to the second power. So you'll get 2x plus 10 equals 4x, which would then have to mean that 2x would have to equal 10, which would give you x equals 5. Alright, let's check this out and make sure that x equals 5 actually holds up to the test. So we have the square root, 2 times 5 is 10, square root of 10 plus 10 minus 2 times the square root of 5 equal to 0. Well, square root of 10 plus 10, that's the square root of 20, minus 2 times the square root of 5 equals 0. Now hang on a minute here. Can we break down the square root of 20? We sure can. That's going to break down into the square root of 4 times the square root of 5. Then you'll have minus 2 times the square root of 5 equal to 0. Well, square root of 4 is 2. So this would give you 2 times the square root of 5 minus 2 times the square root of 5 equal to 0, which would give you 0 equals 0. You got a true statement on both sides, so yes, x equals 5 works and is the solution to this radical equation. So x would equal 5. I got just one more. I'm pretty sure it's a cube root problem too, if I'm not mistaken. Alright. Yep. So we have the cube root of 2x plus 15 minus 3 halves times the cube root of x equal to 0. Alright. So the cube root of 2x plus 15 minus 3 halves times the cube root of x equal to 0. Well, alright, so what we need to do is get this cube root of 2x plus 15 by itself, so that's going to look like the cube root of 2x plus 15 would equal 3 halves times the cube root of x. Now we just raise both sides to the third power. If you do that, you'll get 2x plus 15 would equal 27/8 x. Alright, so now let's simplify this here. So 27 minus 16 is 11, okay? So you would get 11/8 x would equal 15. And then you would get 11x equals 120, which would then give you that x would equal 120/11ths. It looks like we're done, but does this actually work? We need to find out. So you can also substitute this x value into the second step here where I got each radical part by itself on each side of the equation. That works the same as substituting it into the original. In this case, that might be easier to do because we're about to do a decimal approximation all over again. So let's put that value of x in. You'll get 3. Alright, so then 2 times 120 over 11 is actually 240 over 11 plus 15 would be equal to 3 halves times the cube root of 120 over 11. So this is going to simplify into the cube root of 240 plus 165 over 11 equal to 3 halves times the cube root of 120 over 11. So this would turn into the cube root of 405 divided by 11 would equal 3 halves times the cube root of 120 over 11. Now we just take the decimal approximations and see if they match up, if they're in the ballpark. Alright, so let's see here. 405 divided by 11, take that to the 1/3 power, give you 3.327, so 3.327. Now let's check the other side. 120 divided by 11, take the cube root of that. What do you know? You get about 3.327. if I could write. So yeah, the left side equals the right, which means that your x solution of 120/11 holds up. So the solution to this one is x equals 120/11. So that's it for this lesson. Next lesson will be the final in the series, where we will do rational power equations. So I hope everyone has a great day. Take care.